All right, we're going to talk about the pilot, the differences on the pilots on these late model converters versus a conventional small block or big block Chevy, and how that relates to the differences in flex plates. This goes along with the video we made yesterday talking about the converter clearance. Again, on the LS motor, the converter pads should come out 7/8 of an inch away from the block face. If you were to measure that, you can do it on this side over here by rotating the flex plate and doing it like we did on the video yesterday. Most of the LS motors have a dish flex plate like this. Some of the ones that came with a 480 behind them have a flat flex plate that has an adapter between the crankshaft and the flex plate. There's some variations to that. The very early 99, 2000 models had a longer crankshaft, so they didn't have that adapter. But some of you may be familiar with this, but a lot of people, it's a frequent question, so we're going to kind of show it here. When you have the dish flex plate, the factory style converter has a longer pilot, which you can see here. The pilot sticks out further than a conventional pilot relative to the mounting points by about 400 thousandths. So when the converter goes up against the motor, that pilot's in and this hits the flex plate. You have to have a piloted converter. You can't, this has to go in the back of the crankshaft. If you were to put a conventional style converter up there, nothing pilots it. There's nothing to keep the converter centered in the crankshaft. So what we use, and a lot of other converter manufacturers use, we use a pilot adapter. It gives you the extension. So it goes on there and gives you your piloting. You need to check when these are used to make sure the converter can lock all the way against the flex plate. Make sure it butts all the way against the flex plate. It should be done before you install the transmission. Like we showed yesterday, the converter needs to be checked against the flex plate before you do your installation. Otherwise, you can break the pump when you bolt the transmission to the motor and things are not clearance like they should be. Usually these pilot adapters work perfectly fine, but in some cases the billet covers may have some extra meat in this area, and so this pilot adapter doesn't sit down far enough. It would be almost like putting a pilot adapter on one that already has a long pilot. And what you're going to experience is you put this thing together and it doesn't meet. It's usually not going to be quite that large, but you can run into some problems. So that needs to be checked. If you're using one of these and your converter doesn't quite mate up, you can usually grind some off this area or take it to the machine shop and have it turned down. You know, if you get a converter from us, we can machine one custom for you if necessary. But they're made where they typically work and they work well. In some cases, we'll make a long pilot on the converter. It just depends on what we're doing. The reason we like to use the pilot adapter is because if you buy the converter from us and you're currently using an LS motor, later in the future, if you go to say a big block Chevy or some other combo, you can just remove that and you're ready to go. Or if you buy a conventional converter from us and later on you need to go to an LS, you just add the pilot adapter to it. So it makes it kind of a universal setup instead of you having to buy a different converter to get a different pilot or send one in to have it machined. So that covers the pilot differences, mostly with the LS platform where they change depending on the flex plate used. Just for visual reference, again, you can see the differences in the pilot, how far the pilot sticks out from the front of the cover. Over here we're going to show on the 480 specifically when the converter locks in, some of the issues you can see. We're going to do it with a converter that we haven't completely assembled yet, haven't welded yet. On a typical Turbo 400 Power Glide setup like a lot of racers use, you don't have an O-ring on the input shaft here. And the turbine hub of the converter just slides on the input shaft right here, and there's no spot for an O-ring to seal in the turbine hub. On the 480, this ring has to go into this turbine hub, and there's a very slight bevel there to help the ring go in without cutting it. So what we're going to show though, the internet myth is that 2 clunks or 3 clunks and the converter's locked all the way in. One thing we've been preaching for years, and some of the other builders have followed along with us now, is that this actually needs to be measured with a straight edge across the bell housing to the converter mounting pads, like the video we made yesterday and posted. So all the different components have to lock in. The first one that needs to lock in is actually not the first one, it's one of the last ones if you're putting a fully assembled converter on. But the deepest part that locks in are these flats into the pump gears. So we're gonna go ahead and put this on there. All right, that went all the way in, but it's very easy for it to be turned and not all the way in like that. You have to perfectly line it up for it to go all the way back into the pump gears like that. Then we've got the stator with the stator bearings. It has splines here that lock onto the stator tube with the transmission. Okay. And then the turbine has to lock on to the input shaft splines. In the case of a 480, a lot of times this O-ring is hitting this spot at about the same time that the impeller hub is trying to lock into the pump gears. So it'll feel like it's completely in, but it's not. When it's all the way in, the end of the input shaft will be meeting the end of this turbine hub approximately. You're not going to be able to see that with the cover on the converter, with a complete converter. We can see it here. But if you're not all the way in, this is where you'll be. See? That sounds like it's all the way in. But you're not on that O-ring, and you have to turn it, and the pump gears may want to turn when you're turning the converter to get it to lock in. So the little bit of resistance that O-ring creates on the turbine hub may make it feel like it's all the way in. I don't really like to recommend it, but sometimes taking a rubber mallet and tapping the end of the converter slightly while you're turning it will help it run over that O-ring. We have had issues in the past with turbine hub machining being a little off, and the O-ring wouldn't fit very easily in the converter. So that's one thing we check now before we weld the converter together with an input shaft and an O-ring. So when it's all together, it'll be like that. If you were to take a straight edge and measure across here to this area here, it should be a little more than an inch, you know, at least an inch. It should actually be a little more with the way the converters are built. So that should show how the parts lock in onto the input shaft, the stator tube, and the pump gears.